explain what it is we're going to see?
Well, this is a piece of nitinol which was made in the shape of a coil spring, and the property of nitinol is that it when it's hot and wants to get back to the shape it was when it was made. When it's cold, it's quite relaxed and will take any shape. This is now cold, and you see I can take it and stretch it out.
So it was made in the shape.
It was made in the shape that I showed you first. And now it's cold, I can stretch it. Here I have a glass of hot water, and if I just pour the hot water on this thing, you see what happens. There we are. Good as new. In the cool state, it's relaxed and floppy. In the heated state, it remembers its former state. That's why you can say it has a memory. So if you make the thing, if you make this piece of wire so it's straight when you made it, then when it's hot, it wants to straighten out. When it's cold, it's just as floppy as a wet noodle. You know, if you take one of these things and put hot and cold water in your hand, it's like a wet noodle when it's cold. When it's hot, it straightens out very suddenly. It's quite strong stuff.
In a small workshop across from his office, he designed and built a wheel with nitinol loops hanging from the spokes. He calculated that if he filled a container with cold water and another with hot water, the loops of nitinol, moving from one bath to the other, would bend, then spring back, and that the sudden spring of the nitinol in the hot water would drive the wheel around, thus becoming the world's first solid-state heat engine. He was right.
David Porter of Galtech Semiconductors demonstrates his recently patented permanent magnet motor called the carousel electric generator.
This is the latest version of the carousel motor generator. It's a rotary version. Rotary inside. There's 18 separate sections, what we call a coil section in here. 18 make up the outer diameter. There's 6 coils here that we're using to drive the motor. Okay, we don't have an automatic start on the system right now. That's something that the Intel chip will do. We'll start it up at a pulse rate of approximately 13 pulses, which gives us a 16% duty cycle. It takes a while to spool up because, like I say, it works also as its own flywheel. So we build up the power gradually. The thing about this system is that everything floats on the magnetic field in there. You have very little internal friction. What we're doing is removing the energy from the magnet. The magnet has a specific life. They lose approximately 1% a year. So we're not actually trying to create energy from nothing. The system will not run forever. It's not perpetual motion. We use the amount of energy that is in the magnets. Once that energy is used up, the magnets can be taken out, they can be recharged. All we're doing is maximizing the efficiency of the electromagnetic flux density that's there to the production of electrical output.
By stimulating the existing oscillations of space energy, his radiant energy device ran for days, putting out 50 kilowatts of electricity. His public demonstrations attracted newspaper coverage and scientists from Bell Laboratories and the Department of Agriculture's Rural Electrification Administration. Although no one could find evidence of fraud, neither could anyone explain how the radiant energy device worked. During the 30s, he developed semiconductors and transistors that were far ahead of their time. Unfortunately, as all too many inventors have suffered, when he refused to sell out to powerful interests, Moray and his family were threatened, shot at, and their laboratory ransacked. Ignored by the U.S. Patent Office, Moray quietly stopped public disclosure of the device after it was destroyed by his assistant, Felix Frazier, a communist sympathizer who was frustrated when Moray declined his repeated offers to take that technology to Russia.
This torch here is producing a temperature of 1200 degrees Celsius. Now try cooking an ordinary egg like that, and in a very few seconds the results would be quite an explosion. But I'm going to leave this torch here, blowing on this egg for a couple of minutes before we crack it open. And it ought to survive the inferno because it's coated with a remarkable new plastic. What it's made of is a closely guarded secret. All the inventor will say is that 20 years' experience as a ladies' hairdresser led him to the discovery. So, how is it doing? Well, it hasn't broken up at all, and you can see on the front here it's glowing red hot. But just watch this. If I turn the flame off, and remember that it was producing 1200 degrees Celsius, and I take that charred bit and I put it flat in the palm of my hand, it only just feels warm. And if I then crack it open, what's more, the egg hasn't even begun to start cooking.
In Oklahoma, where oil has been king for over a century, inventor Troy Reed has been busy in his shop constructing rotating magnetic motors that he believes will soon revolutionize how we get around.
And it does work. It's 150 volts. What we're going to do, turn off all the switches, make sure there ain't nothing plugged into it. There's the plug. There's your 110 volts. Motor still running. You can operate this table plumb around. Still got energy running. Nothing tied up in the back of it. Nothing on the floor. Rotate around, still running electricity. So we're looking, hoping this time next year that you'll be able to use it in your home. So that's another. And what's good about this, you're talking about electric automobiles, this right here can set it in the back of an electric automobile and generate electricity and charge batteries up in a car. Beautiful automobile. You can drive it anywhere you want to. You don't pollute the air. All the other electric automobiles that I've actually seen has been nothing but this standard transmission. This is an automatic transmission car. There's not a whole lot of what you call junk, I would call, under cars. I've seen a lot of electric cars that had a lot of stuff in it. The only thing that this has a battery to run the radio, the blower. We've got two safety switches over here that can be mounted into an enclosed system, but we did this where you could see, where people can see this car with the technology. It's a safety switch system. This is a controller box, a Curtis control box. It cuts the amperage down. So with the amperage, here's what's real good about electric automobiles. All electric automobiles that has surge technology with this in it, they create heat. They've got to have a fan to blow this Curtis controller off because it gets hot. We don't want that to get hot. We want to stay that cold, because once it stays cold, you save on all the computer chips that's in this controller. So that means you can go farther, longer, and you won't have no problems.
Turn the machine on.
Denny Klein fires up his hot new invention. His machine emits a flame that feels only slightly warm to the touch. But watch what happens when he touches anything else.
Instantaneously, I can burn a hole right down through the center of that brick.
The flame instantly turns hotter than the surface of the sun. Heat so intense it takes only seconds to literally burn a hole through charcoal. 3 seconds turns a brass ball to glowing liquid metal. Tungsten lights up like a sparkler. Steel, lead, and other metals slices on contact. Yet the tip of the welder stays cool to the touch.
No other gas will do this.
Denny Klein uses an alternative fuel source once thought impossible. He says people still have trouble believing him when he reveals his liquid fuel.
Water. Take water and electricity, and we break it down through our very unique electrolysis process.
Klein has just patented his process of converting H2O to HHO, producing a gas that combines the atomic power of hydrogen with the chemical stability of water.
It turns right back to water. You can see the water running off of this.
Klein originally designed his water-burning engine for cutting metal. He thought his invention would replace volatile acetylene in welding factories. Then one day, as he drove to his laboratory in Clearwater, he thought of another way to burn his HHO gas.
On a 100-mile trip, we use about 4 ounces of water.
Klein says his prototype 1994 Ford Escort can travel exclusively on water, though he currently has it rigged to run as a water and gasoline hybrid.
His numerous devices supposedly achieve super efficiency rates by recycling excess energy through closed-loop systems.
I built the world's most efficient heat pump and developed it, and these are the evaporators for that heat pump right here. They're 8 feet high, 3 feet wide. Now, the refrigerant we put in here boils at 40 degrees below zero. Therefore, anytime, day or night, outside in a rainstorm or in a windstorm, a hailstorm or a snowstorm, or just out on a nice hot sunny day or in the middle of a cold night, as long as the refrigerant that's inside this panel is colder than whatever the air is out here or the phenomenon that's hitting this panel, then the heat from the air or the sun or the wind or the rain or the sleet or the snow will be transferred into the refrigerant on the other side, because it's the second law of thermodynamics. Hot goes to cold. So if this is the coldest thing outside, anything out there that touches it is going to give its heat to it. A little bit of heat goes a long way. That gas starts expanding like crazy, and as it expands, it then is drawn into the compressor, not through suction. I've got engineers and inventors that don't like to use the term suction, but through negative pressure. So as the compressor is creating this negative pressure, the gas is migrating to it. And so a compressor is a gas pump. It'll pump gas. And so the gas is being pumped by the compressor into the compressor, elevated in temperature. And even though if you touch this panel, it's ice cold to your hand, and if you touch the line going out of the panel, it's still ice cold to your hand. When it hits that compressor, compressor takes all the gas in this space, puts it in that space, elevates the pressure and the temperature. Going out of the compressor, do not touch that line whenever that thing is on, because it's 200 to 250 degrees hot. And so that's where we get the heat. All of the heat is transferred in here. We then use a compressor to take the relatively useless energy that we've got and elevate the temperature and pressure and make it very useful energy. Then that heat would be transferred later.
This is something you won't see in the world market, because the oil companies, of course, don't want this on the market. It's just a wooden frame. It's got a auto switch on it right here, an automobile switch, which...
I'm going to get closer.
Okay, turns it off and on. I put a cover over it, a jar, to protect it. Now, it's compressed. The material in this is made of, one rod is made of 73 different elements. The other side is made of 74 elements. There's one additional element, and that's why one is negative and one is positive. The one builds up electrons. The neutrinos that strike the Earth 24 hours a day and other things striking the Earth, the combination of them causes electrons to build up in one of these rods, and it depletes them in the other side, much like a solar panel works, very much like a solar panel. But a solar panel needs light 24 hours a day if you're going to use it 24 hours. Otherwise, it only works when the sun comes out. Now, this here, as you can see, very, very light, very light. Has practically no weight to it, but there's plenty of energy there. Now, as I run this up the rod, you can see.
Let me get a little closer there. Okay.
These are Christmas tree lights, 110 volts. So this is a 25-watt bulb. It's 110 and 25 watts. Now, let's see what happens when we put that on. Now, of course, it won't be as bright, because this takes a lot of amperage, you know, and the wattage. This here, the watts on this thing here is only about, right now, about 18 watts only, and this is 25 watts.
Now, do the rods get hot?
No, the rods don't get hot. The light bulb is just hot.
Yeah, because it's...
it gets hot. Now, you need a very big battery to do that, if you want to do that with a battery. You know, that's to show there's no power here as far as storage power. It stores a certain amount of electrons because it builds up. So that we can show they're not like a solar panel. Now let's turn the switch on. So the power is now going from the bottom terminals through the switch here to the top here.
Right, okay.
Now we use these two terminals on here because sometimes at the cave site we used to use this to charge the big battery. You see? So that's why we put those terminals on it. Now let's black it out. See if we can still light it. See what I mean?
Yep.